Okay, so find the radius of convergence and interval of convergence of this series. Okay, we're going to use the ratio test, and let's let an equal to this. The ratio test is this. Okay, we're taking the limit of this as n approaches to infinity. Okay, so if this ratio is less than 1, then it's going to be converging. Okay, so we can ignore the negative because we're taking the absolute value anyways. So we have 3 to the power of m plus 1, x to the power of m plus 1, and it's going to be m plus 2, multiplied by the reciprocal instead of dividing the an. So we get root of m plus 1, right? 3 to the power of n and x to the power of n. Let's line these two up. Line these two up. And line these two up. Okay. So that's going to be 3. That's just going to be x. And this is the same as this, right? Because the degree of the top and bottom is the same, as n approaches to infinity, we can divide the top and bottom by n here to quickly show that it's going to approach 1, root of 1. So this is going to be absolute value of 3x. And this has to be less than 1 to converge. That's the same as this. So it's that. So x has to be in between. So the radius of convergence is this 1 over 3. And our interval of convergence is from negative 1 over 3 to 1 over 3. But we have to check the endpoints to whether to decide whether to include the negative 1 over 3 or 1 over 3. So let's go back up here. What happens if x is equal to negative 1 over 3? Then you get negative 3 to the power of n, negative 1 over 3 to the power of n. So this becomes a 1 to the power of n, right? So it's 1 over root of n plus 1. Okay. And because of the fact that the negative is gone now, and this, right, this is, you can compare it with this one here. Okay. And we know this one here with the infinite series is going to diverge, right? Because of the fact that the power is half. Recall that by p-series test, if this is less than 1, okay, it's going to be diverging. Okay, so we cannot accept this one. Let's now check when x is equal to positive 1 over 3, right? So similar to this, we'll just still have that negative. Okay, negative to the power of n, because there's only one negative here, right? But now this here, right, we know that if you compare with root of 1 over x plus 1 function, it's decreasing, it's approaching 0, and it's alternating. So the alternating series tells us that if it's decreasing and the function is approaching 0, it's converging. So this one we have to accept. So that's why the interval of convergence is going to be not include the negative 3, but include 1 over 3.